Hello and welcome to another video. This is Cracking the Cryptic app, Fog of War pack, puzzle number 17. All sums given. The rules are: Fog of War. Correctly placed digits clear the fog around them. Classic. Every row, column, and box must have all numbers from 1 to 9 exactly once. And lastly, Killer. The cells in each cage must sum up to the number in the top left corner of the cage, and numbers cannot be repeated inside the cage. We are also given a custom note. It says that the number in each cage is always in the top left corner. This is not an additional rule, it's just a hint really. Without further ado, let's begin. This is a really beautiful puzzle, as is often the case when you mix Fog of War with Killer Sudoku. So, over here we have a cage that sums up to number 4, meaning that it is necessarily 2 cells long and contains the numbers 1 and 3. Down here we have 2 cages that sum up to 3, so they're necessarily just 2 cells long and contain the numbers 1 and 2. And the last clue that we are really given is about a cage right here. It goes down, and we don't really know much about it because if you take a close look here, we don't have an indication of what the cells sum up to. And what that means is that the top leftmost part of the cage is hidden somewhere in Fog of War. So this cell right here, that's not actually the top leftmost corner of the cage. And since it is the leftmost corner, right, because we are literally at the left grid, that must mean that it must contain a cell somewhere in the selected row. So one of these selected cells must be the top leftmost cell of that cage. And immediately we recognize that these 2 cells cannot be the top leftmost corner of the cage. Why? Because there is a barrier between these cells and these cells up there, meaning that they're not contained in the cage. What about this one? Can this be the top leftmost corner of the red cage? Well, how would the cage actually reach them? We know that it can't go like this because, as we said, these are not a part of the cage. And it cannot go to the right because there's a barrier in between these 2 cells. It's also not a part of the cage. And since this is not in Fog of War, and we don't see that the cage goes through this cell, it's also not a part of the cage. So the only way the cage could really reach the red cell in the top left would be if it curled like this. But let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would be 10 cells long if this was the top leftmost corner of that cage. But in Killer Sudoku, no cage can be 10 cells long because digits aren't allowed to repeat inside the cage. So if you use up from 1 to 9 to reach here, which are the 9 cells, there is nothing else you could put in the 10th cell except for a repeated digit. And therefore, it cannot be 10 cells long. So that doesn't work. What about this configuration? 1, 2, 3, 4, 5, no, 4, 5, 6, 7, 8, 9. So this configuration is exactly 9 cells long and would work. So what about if this was the top leftmost corner? Well, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would again be 10 cells long. So that would also not work for the same reason as before. You simply run out of digits and you have to repeat a digit. And same is true if this, if any of these were the top leftmost cells. You would have a cage that has more than 9 cells, which is not allowed. So only this configuration works, and therefore this must be the top leftmost corner of the cage. Now, with that in mind, let's fill in every possible value of every other square in this grid. So let's just deselect these 2 because we know what they sum up to. And 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. So we have a pair of 1 and 2 over here, meaning that there is no 1 or 2 anywhere up here. And we have a 1 free pair here, which means that a 1 and a free cannot be anywhere there. And same here, we have a 1-2 pair, so you cannot have a 1 or 2 in this column. So this is a 9 cells long cage, and digits cannot repeat, so therefore it must contain all digits from 1 to 9 exactly once. And the only place it can have the number 1 is right here. Therefore, that is where the number 1 is. And that resolves into a 2 here, and the 1 here, and the 2 and the 1 here. Now, a lot of new stuff was just revealed, and we should be careful with it. But first, the red cage must contain a 2 somewhere, and the 2 can only be up here. So that's the 2. So this reveals a 10 cage, which cannot contain an 8 because it is 2 cells long, as we can see, and a 2 is now here. Now we see a 45 cage. It sums up to 45, so it must be 9 cells long, and we see that it goes down to here. Let's just color it as pink for now. 1, 2, 3, 4, 5, 6, 7. So it needs 2 more cells, and therefore we see that these are not part of the cage, so these are. And now that is 9 cells long. So where does the number 2 go inside the pink cage? It must go somewhere. As we've said, it must contain all digits from 1 to 9. So this must be where the 2 goes. That's the only place for the 2. And now let's check the number 1. The number 1 inside the pink cage can only go here. So that's the 1. And therefore this 10 cage up here cannot contain a 9. It also cannot contain a 5 because it's 2 cells long, so that would be 5 plus 5, and they cannot be inside the same cage. Alright, so what else do we have? We've revealed another cage down here. It's a 12 cage. It is at least 2 cells long. It could be longer, it could be 3 cells, but it does not curl upwards because the indication of what the cell sums up to is in the top leftmost corner of the cage, and so it must all stay on this bottom row. So we're gonna color it orange for now, and we don't know how big it is. And let's see what else we have. So there is a cage that goes kind of like this. Let's color it green. So this cage does not contain this cell because there's a barrier here, right? And let's count 1, 2, 3, 4, 5, 6. It is at least 6 cells long. However, there is no indication of what the cell sums up to anywhere, meaning that the topmost corner, the top leftmost corner, is in fog. But it is already 6 cells long, so if we try to make it go straight upwards to reach that topmost corner, that is going to yield us exactly a 9 cell long cage. So 1, 2, 3, 4, 5, 6, 7, 8, 9, meaning that the lowest length that this cage can have is 9, and the lowest length it can have is precisely in this configuration by shooting straight up. And without that assumption that it does shoot straight up, we run into a contradiction, and the cage would be longer than 9 cells, which we've seen doesn't work. Therefore, this must be the exact shape of this cage. And inside this cage, the number 2 can only show up here, and therefore that is the number 2. Okay, and now there is a 5 cage right here that is 2 cells long, so it cannot contain 9, 8, 7, 6, 5, and it cannot contain a 4 either because there is no 1. 1 is here, so this is a free 2. And so this is 12. It sums up to 12. We're probably gonna leave that be for now. There are better things we can do, I think. Easier things. So a number 1 inside the green cage is either here or here, meaning that it cannot be here. either way or anywhere else in our row. And then what else can we do? Since these two sum up, no, that is actually fine. Well, they sum up to a 9, so they cannot contain a 9. That's at least we can do. So over here, these sums up to 45, which is especially interesting. We see that it does not go here, here, or here. There's barriers. So it must go down at least like this. Let's color it yellow for now. And we do see that there is something here, right? And it does not have an indication of what it sums up to. Therefore, the top leftmost corner of this cage is in fog. Let's assume that this is not the yellow cage. Let's assume that this is not the yellow cage like that. So it is its own thing. Therefore, it must go at least like this, right? But then the yellow cage would be bounded on all sides. On the right side, it has barriers. On the left side, it's bounded by the green cage. And on the right, it will be bounded by the pink cage, which must shoot up in order to get to its top leftmost value. And therefore, this would not be nine cells long, and it sums up to 45, which is a contradiction. Therefore, they must be one in the same cage. And this is, in fact, exactly 9 cells long if you count it. Okay, so now let's check where the numbers must go. The only place for the number 1 inside the yellow cage is right here. So then this is the number 1. And now the place for the number 1 in the green cage is right here. So then this resolves to being a free. And so this is the number 1. All right. So this sums up to a 7. So it cannot be 9, 8, or a 7, or a 6, because there is no 1. Can it be a 4? No, because there is no free. So that's a 2, 5. 2, and then 5. All right. What else can we do? So let's check the ones. The only place for the number ones is here in this cage and here in this cage. So since this sums up to 9, this must be an 8. And since this sums up to 5, then this must be the 4. All right. Now, this is quite interesting. So if you look at this yellow cage, you'll see that the number 3 can only be here or here, and the number 4 can also only be in these two spots, meaning that that's a free 4 pair. So it cannot contain any other value. And therefore, nothing else in this row or box can be a 3 or a 4. Now, since this sums up to 12, and there's no 3 or 4 available, this cannot be a 9 or an 8. And it cannot be a 6 because 6 plus 6 would be a repeating digit. So that's a 5, 7. 5 and 7. Now, this is interesting. So, because a 7 cannot be here, right? And the 7 must show up in this cage, because every digit from 1 to 9 must show up in it, and it's not here, then a 7 must be somewhere here. And therefore, a 7 cannot be up here. Therefore, a 3 cannot be here. Let's keep going. What else can we conclude? So, let's check the 4. Maybe the 1. No, we finished the 1s. Let's check the 2. So, a 2 can only be here. And now, the only place for the 2 in the yellow cage is right here. So then that's a 2, and then that's a 5. So we're done with the 2s and the 1s. That leaves a lot of stuff though. Let's check the free. Oof. Well, maybe this. We can clean this up a little bit probably. So this cannot, neither of these can contain a 6, because 6 plus 6 would be 12, but that would repeat the digit. 3 would pair with the 9. 4 does not have an 8. 5 has a 7. 7 doesn't have a 5. And 8 has a 4, but a 9 doesn't have a 3. Okay? Now, if you take a look at this, you'll see that this is a 6, 7, 8, 9 pair, meaning that the only place where a 5 can be inside the yellow cage is right here. Okay? So, what else can we do? This thing sums up to 10, but there is no 1, so it cannot contain a 9. There's no 2, so it cannot contain an 8. Or a 7, because there's no 3. Cannot contain a 5, because that would be 5 plus 5. So that is a 4, 6 pair. Right? 4 and then 6. Now, if you look at this, 4, 7, 8, 9, that is a quadruple, meaning that 4, 7, 8, and 9 cannot be anywhere else, meaning that this must be the 3. And now 7, 8, 9 and 7, 9, that's a triple, meaning that this must be the 5. All right? Now, so 6, 7, 8, 9, and 6, 7, 8, 9. So this is also a quadruple on the green line, meaning that this cannot contain 6, 7, 8, or 9. And the only place a 6 can be on this green line is here, meaning that this cannot be a 6. And now the only place a 6 can be on the yellow line is up here, meaning that that is the 6. What else can we do? Let's slowly go through the digits. So 3. Can a 4 be here? No, because there is no 8. So this cannot be a 4. So 3 pairs with the 7, 6 pairs with the 4, and then 6 cannot be here. So that's a free 6. And okay, this is a bit hard to explain, but since that is a free 6, that must mean that this thing cannot be containing both the 3 and the 6, because if it contained both 3 and 6, then this would be empty. However, if this was an 8 or a 9, since all digits from 1 to 9 must show up here, if this is an 8, 9, then 3 and 6 are somewhere here, meaning that this would be empty. Therefore, this is not allowed to be an 8 or a 9. It must make place because of this. All right, so 3. And what else do we have? So a 3 must be somewhere on the green line, and it can only be on the green line if it's here or here, meaning that it is nowhere else in the row. And in addition to that, 3 must be somewhere in the bottom box, right? Meaning that it is either here or here. But if it's either here or here, and it must be in one of those two, then it is nowhere else on the pink line. All right. So that's the freeze. And then let's check the 4. It would probably be smart to clean this thing up a little bit first. So this cannot be an 8 because 1 isn't available. Cannot be a 7. Can it be 6 free? That works. 5 4, that works. 4 5, that works. But so this cannot be a 6. Let's go back. Let's do the free, and then 4 5. All right. 6. Where's the 7? So we have no 7s placed. What about an 8? Okay. So an 8 must be here or here in this row, meaning that it must be somewhere here in this box, meaning that this cannot be an 8. And now an 8 must be either here or here in the green cage, meaning that it must be somewhere here in this box, meaning that this is not an 8. Okay. We'll just make sure we're not missing similar stuff. Okay, so number 3 must be somewhere on the red line, right? And it can be either here, here, or here. If it's here or here, then it's not here. And if it is here, again, it's not here. So no matter where you place the 3 cannot be over here. Oops. And therefore a 9 cannot be here. So that gives us a 4 7 9 with a 7 9 here. That's a triple, meaning that this is not 7 9, so this is a 6. So that gives you a double of an 8 9, meaning that this is a 6, and so this is a 7. Since this is 8 9 8 9, then this is a 7, and so this is a 4, and then that's an 8. That's a 9, and so that's a 7. Sorry. So this is a free. Therefore, the free must be over here. And so that's a 7, because they sum up to 10. And then the only place for the free can be here in the red cage. And now the only place for the 6 in the red cage is in this row, here or here, meaning that there is no 6 down here. So let's just go through them more slowly. The only place for the free in the green cage is here, so that's a free. meaning that this is a 9, and then this is an 8. 8, 9, and 8, 9 are a pair, so you cannot have an 8, 9 anywhere here. All right. So the freeze, the fours, and there's a lot more fours. So we have a triple of 4, 5, 6 here, meaning that this cannot be 4, 5, or a 6. That's an 8, 9. And with this 8, 9 here, that's an 8, 9 pair, meaning that an 8, 9 aren't up here. So, check the fours again. All right, 5. So a 5 is either here, here, or here, which means that it cannot be here or here. And actually we have a 5, 9 pair, meaning that a 9 cannot be up there either. All right. So 5. A 5 is here, here, or here. And that essentially means that a 5 cannot be anywhere here. And therefore, a 4 cannot be here because they sum up to 9. All right, now let's check the 6. Okay. 7. So a 7 on the red line can be either here or here, meaning that a 7 cannot be anywhere down here. So that's the 7. Let's check the 8. All right, and lastly the 9. All right, so the only place for the number 5 on the red line, actually there's 2 of them. I didn't see the second one. So let's be a little bit more careful. The freeze don't look like they are very solvable. The force, there's a lot of force, and I am too lazy to think. Therefore, we are going to leave them. The 5, the 5 also has a lot of places. A 6, Hmm. 5, 4. So this would be a 3, this would be a 7, and then this would be 5 and 4. Is that a problem? I'm not sure. So 5, 6, what are we missing? 6, 7, 8. Okay, and then lastly, there is the 9. So if this is the number 4, then this has to be a free, meaning that this is a 6, and that would be a 4, 6, which would mean that this square is empty. So a 4 here means that a 3 is here, meaning that a 6 is here, but a 4, 6 means that this would be empty. That was so easy to miss. And I bet that you guys watching on your side are probably gonna find something else, which is way more simple. And if you did find it, please let me know down in the comments. So this is a 4, 3. That's a 4, 5. And let's see, what else? So now the 3s are all solved. The 4s, they're not solved, but they're a bit ugly still. There's only one place for the number 5 on the red line, and that's here, meaning that this is the 9, meaning that this is a 6, 8, and then that's a 4, that's a 7, 9, 8, 6, and I would not be surprised if the puzzle is just over. So that's a 4, 7, 4, yeah, it looks pretty over. So 5, 9, 7, 9, 8, and that's an 8, 9, that's a 9, 7, and that's a 6, 8, 8, 9, 7, and 5. Alright guys, thank you for watching, and see you in the next one.